All right, so this is still week 5, but lesson 2. And today we are going to use those ideas from the last lesson to move forward and actually solve an augmented matrix. To set the lesson up, let's just go back in history a little bit and look at how we would begin if we were using elimination to solve this example system right here. Okay, so nothing about matrices just yet. Just a little review of not so ancient history. Looking at this system, imagine you wanted to eliminate the y variables. So find those with your eyeballs. And in your brain, what method would you do? What math would you do to get the y's to cancel? I would take the second row and multiply it by 2. Because what would that give me for a coefficient right here? It would give me negative 4y, which would cancel out with this y right above it when you add. And when we did systems before in my classroom, and maybe in Miss Arnold's, I'm not sure, but I introduced a notation system that looked like this. I would write that I would take row 1, that's the first equation, plus 2 times row 2, and then I would add them. So row 1 would be 2x plus 4y equals 6. 2 times row 2 would be 6x minus 4y equals 10. And then when you add, the y's cancel, leaving me 8x equals 16. Now, solving a system using matrices isn't 100% just like this, but the basic idea behind this portion is we'll be using the row notation. We will be thinking about what to multiply certain rows by in order to eliminate certain variables. And those things are going to stay the same. So keep these concepts in the back of your mind as we integrate new concepts using matrices. So let's get to the notes. This yellow is what we're talking about when we say row operations. We're doing operations on rows. The 2 operations I did in that yellow highlighted stuff right here was I multiplied 2 times the second row. That was one operation, the multiplication. And the other operation was when I added the 2 rows together. Okay? That's just some of the operations we can do. Here are the basic, or elementary, in other words. It's all elementary. Watson, isn't that Sherlock Holmes or something? So basic row operations or elementary row operations are these. You can switch any 2 rows if you find that it makes your math easier. You can, on 2, multiply the entries of a row by any non-zero constant. Okay, that's what I did right here when I multiplied a row by 2. And in mathematics, you know, we like to be very specific, so we add in this word non-zero to remind you that you wouldn't want to multiply a row by 0. It would cancel out the entire thing and it wouldn't be helpful to you. In step 3, or option 3, replace a row with the sum or difference of that row and another row. So this was the sum I got when I added these 2 things. And if I was working with a matrix, I could use that to replace a row. And then step 4, you can combine, or option 4 rather, you can combine any of those. Please know these are not steps. You may or may not do all of those in any particular problem. They're just options for you. Now, if you look real quickly at the back of your notes, we will be using those to solve a system, okay? But we're not going to jump right into that. We're going to practice a little bit with the ideas. So we're not solving yet, we're just practicing. So this first example right here, Perform the row operations and write the new matrix. So we're just going to be sure we understand, first of all, what this is saying. And second of all, that we can write the new matrix based on that information. So what that highlighted stuff is telling me to do is to take a quarter of everything in row 2, and that is going to be my new row 2. That's what the arrow is telling you to do. You do the math on the left, and it becomes your new answer on the right, the new row for your new matrix. Notice we're not changing row 1 at all. We are only manipulating row 2. So I'm just going to go ahead and fill in row 1. This is row 1. This is row 2. We're not messing with row 1 at all. But now we are taking a quarter of everything in row 2. So a quarter of 4 is just 1. A quarter of -8 is -2. And a quarter of 12 is 3. So we are just practicing. So now we have this new matrix, yay us. Take a second and look right here at this next example and think about what this might be telling you to do. If you guessed switch row 1 and row 2, you guessed correctly. So this is a whole new example. It's not based on, or actually, yeah, this is a continuation. We'll do a continuation. So the yellow stuff got me from here to here. That green highlighted stuff is going to get me from there to there. So that just means switch your rows now, and row 2 becomes row 1. And row 1 becomes row 2. Okay? So that's just practicing with the notation. So read the directions for this next example. It says perform the indicated row operations and write the new matrix. That's part 1. Part 2, what row operations would produce zeros beneath the second entry in the diagonal? That was a lot of words. Don't even think about 2 right now. We'll do that in a second. Just let's talk about the first one. Perform the indicated row operations. Well, okay. Here are the indicated row operations. Think about what that's telling you to do. It's probably clear that it's telling you to take -3 times everything in row 1, 2 times everything in row 2, and add those things together. That's fine. But what is it telling you to do with that information? Once you add them, once you do all of this, that becomes your new row 2. Please understand, I'm doing -3 times R1, but this is not a permanent change. The only thing I'm permanently changing is row 2. So this math, the -3 times row 1 and the 2 times row 2, is just math I'm doing as a means to an end, as a way of getting a new row 2. But row 1 does not change permanently. So here's how this is going to look. So -3, row 1, I'm going to add that to 2 row 2. And it's going to give me my new row 2. So here's what -3 row 1 looks like. -6, -3, +3, and +9. 2 times row 2 looks like this. 6, dang it, 6, 2, 2, and 2. Now we add those. I've got nothing. I've got -1, +5, and 9. So what's happened here? What's eliminated? The x value. Anytime you can eliminate a variable and cut it down to 2 or less, that's good. that means you're getting closer and closer to solving the system. Okay, so basically that's elimination. So this is going where in my new matrix? Is that row 1, row 2, or row 3? Right, that's the new row 2. So I'm going to fill that in. And remember what I talked about a little bit earlier. This math I did to row 1 is not a permanent change. It was just to eliminate the x. So row 1 is going to stay the same. That's a very important distinction. We did math to row 1, but it was not a permanent change. It was temporary. The only thing that permanently changed was row 2. And then row 3 is the same as well. And now that we've done that math, I kind of want to backtrack a little bit and just pretend like we were thinking about this from the beginning before doing any work. What we just did effectively was eliminated. We used this number, these two numbers, 2 and 3, which, by the way, represent x's. This is your column of x coefficients, y coefficients, and z. And we thought about what math could we do to eliminate that? Well, we can take that 2 and multiply it by -3, and take that 3 and multiply it by +2. But just like when we did elimination a few units ago, you had to do that to the entire row. And so that's what happened. The x got eliminated, and that became my new row 2. Okay? So using this new matrix that I wrote right here, what color highlighter have we not used yet? Purple. So now we're here. So this is the new matrix that I'm working with. And I'm now going to do that operation, all that combination of row operations. And I want you to pause the video, look at what this notation is telling you to do, and think about what is that going to end up looking like? What variable gets eliminated again, or possibly new variable, after I do this stuff? So I want you to pause and think about that. Hopefully you realized that what this will do is make a 0 right here. Here's how that math will look. -2 times everything in row 1 plus row 3 gives me my new row 3. So -2 times row 1 looks like this: -4, -2, +2, +6. Row 3 doesn't change at all, so I'll just write it down. 4, 3, 2, 3. And now you add everything vertically, so the 4's cancel. -2 plus 3 is +1, and then 4, and then 9. And where is that information going to go? That's right, row 3. This is my new row 3. I'm going to fill that in. That is the only row I changed from the purple matrix. So row 1 and row 2 stay the same, and I'm going to fill those in now. That was terrible. All right. So if you remember yesterday, we talked about a triangular form of a matrix where if you identify the diagonal and everything under the diagonal and to the left is zeros. That's the triangular form. Is this triangular form? No, not yet. Identify the one thing that needs to be changed in order to complete this into triangular form. I hope you came up with this right here. That value would need to be a 0. So going back to the instructions for this example, step 2, what row operations would produce zeros beneath the second entry in the diagonal? Well, look at that thing I highlighted. That is beneath the second entry in the diagonal. The second entry is the -1 right here. So in order to get this in triangle form, we want a 0 right here where that 1 is. So I want you to pause the video, erase those black marks so you can see everything. Looking at this matrix, this is the third iteration of our matrix. This is where we are now. Pause your video and think about what math can you do to get a 0 where that highlighted 1 is. And I'll give you a couple tips. The first tip is, if you are trying to manipulate a certain row, and I don't mean buying you like chocolates and Valentine's for Halloween. I didn't even get that whole joke right for Valentine's Day, which is really quite awful in the first place. You don't want to manipulate people to buy you stuff because it's dishonest. Come on, guys, stop doing that to your girls. You know that's what you do. You always want chocolates and flowers for Halloween. Okay, so whenever you're trying to manipulate a particular row, so in this case, we're trying to manipulate row 3. Okay. When you're trying to figure out your order of operations, you have to include that row in your math. But you can pick any of the other 2 rows to combine with it. So while you were thinking about which rows to combine, you don't have to go exactly what I did, but to my mind, the easiest 2 rows are row 3 and row 2. How come I think those are the best rows? Because I'm trying to eliminate that 1 that I highlighted with yellow. And if I add it to this one right here, they will eliminate. So let's do that. So if I take row 2, the way it is now, and add it to row 3, those middle numbers will cancel out, and I don't have to do any other math. I don't have to multiply anything by anything. They are already good to go. So I'm just doing row 2 plus row 3. And which new row will that give me? Row 3. So basically I'm doing this. Row 2 plus row 3 gives the new row 3. Okay. So row 2 is 0, -1, 5, and 9. Row 2 is 0, 1, 4, 9. Add. See how the ones on the left, the x values were already zeros? That's so good. Because what happens when you add zeros? Does anything change? No, it's still 0, which is what we want when we're trying to get it in triangular form. -1 plus 1 is 0, and then we have 9 here and 18 here. So if I rewrite now my entire matrix, row 1 and 2 just stayed the same, right? I only changed row 3. So I've got 2, 1, -1, -3. 0, -1, 5, and 9. And my new shiny row 3, 0, 0, 9, 18. So this would be so easy to solve using our skills from yesterday. We'd start here. That's 9z equals 18. We'd solve for z, and then back substitute and back substitute. All right, so now that we have practiced all the basics, let's go to some examples where we do this again. We triangularize and then actually finish out solving. So on the second page of your notes, we are now moving into solving systems with matrix row reduction. Row reduction is the process, so we're here, of performing elementary row operations on an augmented matrix to solve a system. Does that sound like a lot? We just did that. That is what we did here on the bottom of the first page of your notes. So you already know how to do it. We're just putting fancy math words to it. It's called row reduction. To review real quickly, which I already talked about too, the triangle form of a matrix is where all the entries below the diagonal are 0. The bottom equation indicates the solution for that variable. Right? It's the solution because it's only got one variable left in the z spot. So to triangularize your matrix, 1, write your system of equations as an augmented matrix. Okay, that's easy. 2, utilize elementary row operations to get zeros under the diagonal entry in the first column. Notice right here, if you're solving a 2x2 system, skip to step 4, okay, because it requires less work. Step 3, utilize elementary row operations with row 2 and row 3 to get zeros under the second diagonal entry. And then 4, convert back to equation form and substitute values into your equations from the bottom up to back solve for your remaining variables. Okay. So a couple things, while I read that to you, you might have zoned out and started thinking about all the things you're going to do when you're out of quarantine. So let's kind of go back a little bit and pull out some things I want you to pay attention to. First thing you're going to do is take your system and write it as an augmented matrix. Okay. The second thing you're going to do is get a 0 under the diagonal entry in the first column. That's a very specific place. The third thing you're going to do is use rows 2 and 3 to get zeros under the second diagonal entry. And then 4, you're going to back substitute. All right. So moving straight to the examples, it says, so I'm here. Solve each system by triangularizing the augmented matrix and using back substitution. In this example 1, is this a 2x2 or a 3x3 system? Yeah, a 2x2. So what did this yellow highlighted stuff say if you have a 2x2? It's a skip to step 4. So convert back to equation form and substitute values into them to go back. So we're only doing steps 1, 2, and 4. So let's talk about step 1. Write it as an augmented matrix. So you take a minute to do that. Pause your video. You should have written this. 6, dang it, not y. I want the y. 6, 1, straight line 9, and then 3, 2, straight line 0. Okay, there's step 1. Done. Step 2, use row operations to get zeros under the diagonal entry in the first column. All right, well, first of all, here's the diagonal. Second of all, what's the first column under the diagonal? Well, in this case, it's just this. It's the only thing under the diagonal because this is a 2x2. So we want to use row operations that get a 0 right there where the 3 is. I can't add them right now. If I added these two things right now, I would have 6 plus 3 is 9. I would have a 9 as my new row 2. So think about what kind of math can I do to get these two things to cancel out. Hopefully you said multiplying the second row by -2. So here's the notation just so you can see it. That means I'm taking row 1 plus -2 times row 2. Now, which row is that going to replace? Is that going to replace row 1 or row 2? Well, if your goal is to get a 0 right here, then shouldn't you be replacing row 2 so that it can be changed? So here's how that will look. So I've got row 1 plus -2 times row 2. It's going to give me my new row 2. So I've got 6, 1, and 9, -6, -4, 0. Adding those gives me nada, -3, and 9. So my new matrix looks like this. 6, 1, 9, 0, -3, 9. So my triangular form is done. So I have only zeros under my diagonal. Now I can back substitute. So looking at the row 2, what does this indicate as far as variables go? Am I about to solve for x or am I about to solve for y? Y, right? Because the second column right here represents the y variables. So it really means -3y equals 9. So what do I do to solve? I divide both sides by -3. Because remember, this represents equals. That straight line. So now I've got y equals -3. And then I back substitute that into the first equation, which represents 6x plus y, which is now -3, equals 9. So that's really a -3, really. We're just trying to be like technical. Or I should say minus is really a plus and negative, but whatever. So then add 3 to both sides. 6x equals 12, x equals 2. Don't forget to write this answer as an ordered pair, where x comes first and y comes second. And then here comes Z and a baby carriage. All right, so that was just a little baby problem. We are leveling up 3 levels at least for this next problem. Maybe 2.5 levels. I'm going to erase the stuff from before just to give myself a clear space to work. Go back and look at step 1. It says, write your system of equations as an augmented matrix. So take a second and do yours. I'm going to do mine. Don't look at mine until you're done with yours, because you can't unsee what you've seen, and then you might feel like if you just look at what I do, you might feel like you know what to do when maybe you don't really. All right, so let's compare. The only real mistake I might see y'all making is not paying attention on row 3 and feeling like since there's a blank in the front that x is 0. Did you put 0 for x? Check your third row and make sure it matches mine. It's the y variable that's missing. So y gets a 0. All right, so there's step 1 done. Now go back and look at your step 2. Use row operations to get zeros under the diagonal entry in the first column. A 0 under the diagonal entry in the first column. So let's be sure we know exactly where that is. First, find your diagonal. Diagonally. And then where's the 0 under the first column? Where do you want a 0 to be? Where is the position under the first column in your diagonal? It's right here. Your first step is to get a 0 where that green thing is highlighted. So pause the video and think about what combination of rows and math you can do to cancel out that 1 right there. here's what I'm going to do. This makes sense to my brain. I'm going to do -2 times row 2. Because that would give me a -2 where the green is, and I can add it to row 1, and that would cancel out. So here's what I'm going to do. I'm going to do -2 times row 2. I'm going to add it to row 1. And remember what I told you before, if you're trying to modify a row, that's going to be your new row. So once I do that math, it replaces row 2. That's my new row 2. So -2 times everything in row 2 gives me this, -2, -4, +2, +6. Row 1 stays the same. And I'm going to add vertically. So I got nothing here. I've got -5, +5, and 20. This only replaces my row 2. The other 2 rows are going to stay the same. My new row 2 is 0, -5, 5, and 20. And row 3 stays the same. So a couple of heads up here. Oh no, never mind. One head up. The only thing that changed was row 2. And the good thing about what changed is there is now a 0 under the diagonal. In fact, how many zeros do you see under the diagonal? 2 so far? We really want to get a 0 where that 4 is so that we can start back substituting. So now we go to the next part of our steps. So go back up and read step 3 to yourself. It says to use row operations on row 2 and row 3 to get zeros under the second diagonal entry. Now, sometimes when you're doing your operations, this 0 right here, we're just kind of lucky it's there. It may change when we do our next row operation. And if it does, we will just do one more round of row operations to get rid of that. Basically, here's the order that you want to get the zeros under the diagonal. You want to do them in like an L shape, like that. You want to do the 0 here first, the 0 here second, and the 0 here last. Okay, that represents the zeros under your diagonal. Okay, so we've already done, hey, that looks like, what is that, like a football player or something? So we've already done this 0. We have a 0 here, but that could change. If it does, we'll take care of that later. We're focusing right now on this 0 in the bottom left corner. So look at your rows and think about what math you can do with row 1 and row 3, or row 2 and row 3 to get a 0 there. So here's what I'm going to do. I'm going to take -2 times all of row 1, because that will give me -4, which will cancel out with this 4. All right? So I'll take -2 times row 1, add it to row 3, and which row is that going to be replacing, that answer? It's going to be replacing row 3, because that's where I want the 0, is right here in row 3. So -2 times everything in row 1 is -4, +2, -6, -28. Row 3 doesn't change. I have 4, 0, -2, 2. And now I add. These cancel, -4 and 4. That gives me 2, -8, and -26. So let's write the new matrix. So this matrix right here, this one, is the one I'm updating. The one we wrote originally, I'm not using any of those rows anymore. This, as far as I'm concerned, is my new matrix. And now I'm changing it again to this one, where only row 3 changes. Row 3 is now 0, 2, -8, -26. Even though I did math on row 1 to make this happen, I did not permanently change row 1. So row 1 stays 2, -1, 3, and 14. And then row 2 is this. Right? So notice the 0 that I had here, that I highlighted in that funky blue color, right here, is no longer a 0. And that's okay. Don't even, if you see that 0 in the future, like, don't get excited about it, because it might change. We're gonna fix it now. So remember, we did the zeros in this order, like an L. We did this 0, and now we're gonna make this a 0. So take a minute, look at your matrix, and now read step 3. I'm sorry, I told you to read step 3 earlier, but we weren't quite there yet. Step 3 says use row operations with strictly row 2 and row 3 to get zeros here. So now don't worry about row 1. We're going to do math here and here. And I want you to think about what that math is in order to get the -5 and the 2 to cancel out. So pause your video and think about that. I hope you came up with this, multiplying the second row by 2 and the third row by 5, because that will give me a -10 here and a +10 here. So I will do 2 times row 2 plus 5 times row 2. Sorry, row 3. And which row will that be replacing? When I get this answer, it's going to replace which row? Row 3. So here's the math. 2 times row 2 is nothing here. Then -10, +10, and 40. And row 3 is 0, +10, -40, and then -130. So now we add. I have 0, 0, -30, and -90. So here's our final new matrix. So this just replaces row 3. So now row 3 is this. And then row 2, even though I did math to it, it was not a permanent change because I wasn't updating row 2. I was just manipulating it for my purposes. Okay, so now we have triangularized the system. And even though we started this problem like 12 years ago, we're not done, because this wasn't the point or the final point. The final point is now that it's in this form, we can back substitute to solve for x, y, and z. So we start with the bottom row. Remember, this third column represents the z's. And this is your y's, and this is your x's. So that bottom row really means -30 z equals -90. To solve, you just divide both sides by -30, and z equals 3. Okay, that's cool. Back substitute here. I have 0 x's there. I have -5 y's plus 5z. I now know that z is 3 equals 20. That's plus 15. I subtract that from both sides. And I have -y equals 5. Divide by -5. Y equals 1. So I got this. I got that. Sorry, y is negative. So then I take those two things, the y and the z, and I back substitute into the very first equation. And to solve for x. So I've got 2x minus 1y, where y is -1, plus 3z, where z is 3, equals 14. So -1 times -1 is +1. Be careful with your negatives. 1 plus 9 is 10. And I'm going to subtract that from both sides. 2x equals 4, divide by 2, x equals 2. Last but not least, oh my gosh, this is the longest lesson that ever existed in distance learning. X is 2, y is -1, z is 3.